Hello, everyone, and welcome to BRIC 2021. My name is George Dwinvich, and before we begin with our formal opening introductions, on behalf of our host, the Waterloo Institute for Nanotechnology, we respectfully acknowledge that much of our work takes place on the traditional territory of the neutral Anishinaabe and Haudenosaunee peoples. WIN and the University of Waterloo campus are situated on the Haldimand Tract, the land granted to the Six Nations that includes 6 miles on each side of the Grand River. It's my pleasure to introduce our organizing committee and moderators for the event, which includes Lisa Prokryats, Assistant Director of Research Programs at the Waterloo Institute for Nanotechnology and Local Organizing Chair, Shannon Gordon, co-founder of BRIC, and formerly with the University of Waterloo. Jeffrey Demain, Bibliometrics librarian at McMaster University, and myself working as a collections librarian for science, engineering, and design at Carleton University. For those unfamiliar with BRIC, we launched our first event in 2017 to provide a forum to advance the skills and knowledge of library and information professionals supporting research impact services and initiatives. Our key annual event has grown substantially, and this year's attendees not only includes participants from across Canada, but we have colleagues joining us from Australia, Germany, Hong Kong, India, Mali, Netherlands, South Africa, Spain, United Kingdom, and the United States, and I may have missed one or two. We really hope that you learn a lot from this year's event and are already looking forward to seeing you in person at a future BRIC event. A few practicalities to share with you. If you're posting on social media, please use the hashtag BRIC21. For Q&A, we'd like you to use the chat feature and direct the question to host Isabella McKenzie. This info will also be on our WebEx event page on the BRIC website. If you're leaving the event early or just attending 1 or 2 of the days, please consider giving us feedback nonetheless using our form linked at the bottom of our program page. And for presenters, our moderators will be providing you with a gentle nudge when the time limit is approaching. If you miss a session, we are hoping to have many or most of these posted to our forthcoming YouTube channel and or the WIN YouTube channel. We'll update you when that's taken place. And also please note the more detailed presenters' bios and affiliations in the full program. Special thanks to our local organizing committee lead, Lisa Prokryats, who worked with BRIC and our sponsors last year to prepare a fabulous in-person event that unfortunately last minute couldn't take place, as well as her colleague Bella McKenzie, who has also provided us with logistical and technical support as we move to the virtual format. And of course, we're super grateful to the Waterloo Institute for Nanotechnology for hosting us not once, but kind of twice in a row since last year was canceled. At this stage, we would like to introduce you to Sushanta Mitra, who will open the event on behalf of the Waterloo Institute for Nanotechnology. Professor Mitra is the Executive Director of the Waterloo Institute for Nanotechnology and a professor in mechanical and mechatronics engineering, also cross-appointed as a professor in the Department of Physics and Astronomy, as well as the Department of Chemical Engineering at the University of Waterloo. Our BRIC team is incredibly thankful for his and WIN's ongoing support and encouragement for this event, and I'll turn it now over to Professor Mitra.
Thank you so much, George, and good morning, good afternoon, and good evening, wherever you are across the world. And that's the beauty of these virtual platforms. We are able to welcome a huge amount of attendees across the globe. And we at WIN and at the University of Waterloo, we are really thankful that we could partner with BRIC, an extraordinary organization who is championing which is very critical in today's research ecosystem, is to understand the impact of the research, and using bibliometrics as one of the tools to do that. So we are really excited and honored to be part of it, and we are working diligently within our community, within our different units at the university to champion bibliometrics, and definitely BRIC 2021 would be a great way to encourage the community within the university across the Canadian partner institutes to work towards this exciting opportunity of letting us create this understanding of how we can evaluate and appreciate research impact within our community. And we really like to thank the organizers here, as well as Lisa, who has worked a lot with this organization committee, as well as Bella, to provide all this logistics and help. The program is fantastic. I'm looking forward to attending some of these sessions, and particularly when I see such a diverse audience and speakers that you are able to put together, looking at UN SDG goals of impact to traditional bibliometrics, CIVAL, and so forth. So this is quite exciting. And so again, thank you so much. Chi miigwech, merci beaucoup. Have a great conference.
Thank you very much, Professor Meacher, for that wonderful introduction. I think we're now able to kick off with our keynote address. Those of you in Canada, of course, and internationally will know Dr. Vincent-Larivière is an important contributor to the field, and we're very pleased to have him speak to us. Professor Larivière holds the prestigious Canada Research Chair on the Transformations of Scholarly Communication at the Université de Montréal, where he's a professor of information science, and his teaching includes research methods and bibliometrics, amongst other topics. Also Associate Vice President, Planning and Communications. He is the Scientific Director of the Erudite Journal Platform, Associate Scientific Director of the Observatoire des Sciences et des Technologies, OST, and a regular member of the Centre interuniversitaire de recherche sur les sciences et la technologie. Professor Larivière, we're super pleased to have you address our BRIC community, and I will turn it over to you.
Thanks so much. I'm very happy to be with you this morning. I wish that was an in-person event, and I guess we're going to go back to that at some point, but we're not there yet. So let me try to share my screen. I assume that you guys can see my screen now. Okay.
Yep, all good.
Okay, thank you. Yeah, so what I want to talk today is about a thing that is actually quite common in science, which are self-citations. And as we'll see, self-citations have a bad press, although they are, for many, considered as a normal thing that is happening in science. So we're going to try to understand that phenomenon better using two analyses that we've done in my team. So this is a joint work with Phillippe Vincent-Lamare, who's a postdoc in my lab, and my colleague Cassidy Suigimoto from Indiana University in Bloomington. So a quick outline of what I'll discuss. So I'll give a broader context of the rise in research evaluation, and then we're going to go through a couple of the, let's say, common criticisms that are made to citation analysis. Then we'll discuss actually a couple of misconceptions around self-citation, and then we're going to look in detail at two original analyses. So this is yet unpublished works. It's stuff that we're kind of still doing, but I wanted to show you what's kind of at the forefront of the research. So we're going to look at both self-citations and self-reference as a function of the career of individuals. So of course, I will explain the distinction between the two notions. And then we're going to look at the semantic similarity between citing and citing papers. And then I'll conclude on basically what does it tell us on self-citation. And in the end, I think you guys understand what the goal of that is should we actually include self-citations or not when we are doing citation analysis? So the general context is one that you are mostly aware of. So there's a growth in research evaluations that are based on bibliometrics. And of course, the level to which these bibliometric analysis takes place varies by countries. In some countries, they have actually replaced almost entirely peer review. So some countries evaluate researchers almost exclusively through bibliometrics. In other countries, and among them Canada, they are kind of used as a complement to peer review. So we did not move like in Belgium and like in many of the Nordic countries to a kind of a very centralized bibliometric system. There's a lot of bibliometrics going on in the country, and your community is an example of that. But still, it's not as intense or invasive, I would say, as in some other countries. They form, of course, one of the reasons for the use of bibliometrics in research assessment is that they form the basis of most university rankings. And we know, though, that these bibliometric evaluations are kind of changing the incentive structure of academia. It's changing the way researchers behave. As you are probably aware, there's many countries, among them China, and as well as some of the Scandinavian countries that actually give salary bonuses based on the impact factors of journals in which researchers publish. So for instance, in some universities in China, if you publish a Nature or Science piece, you can get around 165,000 US dollars. And this is not money for your research. This is really money that goes in your pocket to buy yourself a new car or a couple of new cars or a down payment on a house. So this is really something that is kind of a game changer personally. And so, of course, that creates a lot of pressure to publish in those journals because the incentives to go publish in these high impact journals are not only in terms of symbolic capital and prestige, they are also associated with economic capital. And so the race to publication is, I would say, relatively recent. And we've got interesting contrast here with, let's say, older researchers. So right now, researchers need to publish to show that they exist. So historically, you would publish when you found something. Now you publish to signal that you are actually doing something, that you are doing research. So it's a signaling device for research activity. And again, we can contrast that with Peter Higgs, who's the, when they say inventor of Higgs boson, who published his last paper in 1979 and won the Nobel Prize in 2013. So basically, Peter Higgs considered that he had nothing to add to the discipline anymore, that there was no interest in him rewriting the same pieces over and over again. So he stopped publishing more than 40 years ago, which again reminds us that you don't win the Nobel Prize or you don't cure COVID by your number of papers. You need one good paper, one important discovery to change science. So that's kind of the general context. So in that context, citations are quite important, but historically they have been shown to be problematic. So there's a couple of criticisms of citation analysis that date back to basically the creation of the Science Citation Index in the 1950s. And they've been, let's say, repeated by many researchers. They've been, some are right, some are wrong. And so we're going to go through those, and then we're going to end up looking at self-citations as one of these criticisms of citation analysis. So the first criticism is that it takes time for citation to accumulate. So when a paper is published now, you have to wait a couple of years for citations to accumulate and therefore to measure the impact of a given piece of research. And by impact, I mean scientific or research impact. That's one of the many types of impact that science can make. So of course, it's important to recall that citation is not an indicator of social impact or economic impact. It's an impact of a piece of research within the scientific community. The second criticism is that there's historically a lot of influences that remain uncited. So the things that you cite are not necessarily the entire set of papers and ideas that you've read about or that you've discussed about. It's a subset of all of those things which you in the end decided to cite in a given piece. One example of that is a phenomenon that's called obliteration by incorporation, which was coined by the sociologist Robert Merton. But basically, some of the biggest influences in the end become part of the common knowledge of a field, and they won't be cited anymore. So take, for example, Einstein. Einstein is not cited anymore, but in his 1910 or 1911 pieces are not cited anymore by physics papers, despite the fact that it's at the heart of the many things that are being done. In a way, in that case, not being cited is the pinnacle of being canonized as an important researcher. A third criticism is the existence of negative citation, so that pieces are actually cited because they are being criticized, they are being shown to be wrong. We did an analysis on that, we're going to spend a little bit of time on this criticism. So with my colleagues in Indiana and in the Netherlands, we actually had access to a couple of million papers published by Elsevier journals, and we extracted the citation context of the cited references. So basically, that means taking the entire sentence where the paper is cited, as well as the sentence after and the sentence before, to try to get an idea of the context in which a piece of research is cited. And so we came up with a couple of linguistic markers of negativity or criticism, and tried globally to assess what's the prevalence of disagreement or of negative citations across different subfields. And so what you have on the figure on the right is the percentage of references that are cited in a context of disagreement. And I think you all see that the percentage is very low. So it's less than 1% of cited references that are cited in a globally negative context. What's quite striking, so first thing here is that, okay, so negative citations are not so much of a problem. Most cited references are either neutral, so they're just mentioned, or they are positive, and there's a tiny subset that is negative. But the other thing is that the level to which, or the proportion of negative citations actually follows Auguste Comte's hierarchy of the sciences. So social sciences have a higher level of disagreement, and math and computer science have a lower level of disagreement. So according to Comte, social sciences is a field that are fields that are more complex, and therefore there's less consensus in the research. Physics, on the other hand, is actually less complex and is more consensual. And this can be considered a bit controversial to a couple of you. Maybe there's physicists here that say our fields are actually very complex. Globally, there's a general agreement that social phenomena are actually much less predictable than physical phenomena, which explains the more complex aspect of social sciences and the less complex aspect of physics. So regarding that, let's say that criticism of citation analysis, we can say that, well, there's actually not that many negative citations happening in science, but there's more in the social sciences because there's multiple paradigms competing. There's many ways one can do sociology, while there's actually not 25 ways people can do math or physics. Quite interestingly, we see a couple of trends over time, especially in physics and engineering and math and computer sciences that are the two curves at the bottom, where we show that researchers seems to disagree less and less. So the trend is not that strong, although it is quite clear in physics and engineering that basically goes from 0.2% to 0.1% over about 16 years. So very few disagreement, and these disagreements are actually decreasing over time in some of those disciplines. Moving on to other criticism of citation analysis, one that is quite commonly mentioned is what is called perfunctory citation. So those are citations that are actually just mentioned in passing. It's citations with which there's very little engagement in a given piece. So the reference is there just to show that the authors have a knowledge of it, but it's not necessary to have this reference to understand the content of the citing paper. One way to look at that is actually where are papers cited in a given piece of research. So that's from a paper we did a couple of years ago, where we extracted all cited references published in PLOS journals and then mapped them on the text progression, which is what's on the x-axis here. And what it shows is that most of the cited references are in the introduction to basically set the table, to show prior research, to frame the paper. There's actually very little cited references in the methods and in the results. And then there's a subset of references that are in the discussion. And by subset, I mean that these are often cited references that are both in the introduction and then in the discussion, with which basically the authors will be comparing the results obtained with what the literature was saying. So in a way, the only references that matter, or a large proportion of the references that matter, are those that are in the discussion and in the conclusion. Those that are in the intro are probably a bit less important. So there's a sizable proportion of references that are, one may say, not that necessary, but that they serve a role to give credit to those who have worked on the topic before, etc. Another common criticism are uncited paper, and this is something that comes back commonly in the scholarly literature. That, well, most research is useless, most papers are uncited, etc. That, of course, is false. Of course, at publication, on the day a paper is published, it has 0 citations. Of course, preprints have changed that a bit, but globally, most papers that are yet published or that have just been published are not cited yet. It takes time for citations to accumulate, and therefore it takes time for papers to be cited at least once. When we look at things globally, we see that after a couple of years, in almost all fields, papers are cited at least once. And in the health sciences, in psychology, in earth and space sciences, 90% of papers are cited at least once. And this is what we observe basically in almost all fields. The only 2 broad domains where there's a lower proportion of cited papers are arts and humanities, mostly because, well, they work on a different time scale. So it's history, literature, etc. So papers may be cited, but in 50 years. But also, these are Web of Science data and therefore exclude books or exclude most of the books. And so citations coming from books are not included in there. So globally, papers are cited. The uncitedness is not really a problem in science. Then we move on to the core of our analysis, which is, okay, I'll say a couple of words on citation cartels and then move on to self-citations. So of course, citation cartels are a genuine problem, especially at the journal level. What are citation cartels? Basically, journal A cites journal B cites journal C cites journal D, etc. So there's basically a group of journals that pulls their references together to try to help everyone and rise their level to increase the impact factor. So there's a couple of dozen of journals that have been found guilty of that, and Larivière has basically banned them from having an impact factor. Now, self-citations. So these can be observed at several levels. What we're going to do mostly during the talk is to talk at the individual researcher level, so basically at the level of those who are making the cited references. But those exist at the level of journal, they exist at the level of countries, they exist at the paper level, and they exist at the researcher level. And I'll make an important distinction between paper level self-citation and researcher level self-citations. So interestingly, there's a rise in the proportion of journals that actually cite papers that fall within the impact factor window. And this is seen as kind of a way for journals to increase the value of the impact factor. So as you recall, the impact factor is based on basically papers published in the 2 previous years of a journal, and journals are increasingly citing papers within that window. Either it's due to the fact that science goes faster, so we cite younger paper, or it's due to, let's say, a little bit of a deviant behavior in terms of journal level self-citations. Then at the level of countries, we observe that indeed every country is citing its own research more. This is true basically for every country. Of course, as you can see here, every country cites the United States a lot, cites the UK a lot, but also individually, which is a diagonal, every country cites their own research more than expected, which can be explained in many ways. One of them is the national relevance of research. So that's especially true in the social sciences and humanity, but it's also true in all sciences, and even in the natural sciences, where you are more likely to be aware of things that are being done within your institution or region than what is done internationally. Moving on to self-citations. So basically, there's two conceptions of self-citations in the world of research. The first conception, one may say, is a relatively positive one. So that self-citations are a normal feature of research activity. So when you start your career, you work on a given topic, you're going to do your master's thesis, then you'll probably do your PhD thesis in a related topic, then your postdoc. And when you become, let's say, more of an established researcher, you won't change topics. So the fact that you cite your previous work is kind of just a normal thing that's related to the progression in your career. So you build on what you did in the past. Research has also shown that self-citations are more frequent in smaller fields because, again, just from a probabilistic point of view, you are more likely to find your own paper in the pool of papers that exist in your field. We also need to remember that to self-cite yourself, you need to publish an additional paper. So it's not like tweeting your own paper. To tweet a paper, there's no barrier to entry. There's no gatekeeping. In the case of a self-citation, there's going to be a gatekeeping because you need to go through peer review. And again, your paper needs to be accepted by peers, including those self-citations. So in that way of seeing things, self-citations could be considered in research evaluation. They are part of the normal career path of researchers. The other conception is one that is a bit more negative, where self-citations are a deviant behavior. So the notion of impact can be considered as having impact on others, not on yourself. And so they should be, in that case, excluded for research evaluation. So self-citation would be done just to increase your own scientific impact, and therefore they should just not be counted. So and these two conceptions have been seen and they've been existing, cohabiting in the literature for decades. Our goal here is to try to kind of see where things fall using an empirical analysis. That's, as you'll see, quite large scale. And of course, like we've got here an interesting example of extreme self-citation behavior. So paper with more references than words. So the paper has 182 words and 212 references, and all of them are from the first author. So it's all self-citation. Again, this is an extreme example of a deviant behavior, and I'm saying deviant in a kind manner here. So that's kind of an extreme behavior. But as you know, there's researchers that are probably erring on the on the borderline behavior in terms of self-citations. So first conceptual issue, and this is crucial. I hope you're all following me. So we need to distinguish self-citations from self-references. So self-citations are, of all of the citations that I've received, what's the proportion that I made myself? So it's basically of all of the credit that has been given by the community, what's the proportion that I've received? In terms of self-references, it's slightly different. So it's of all of the references that I made myself as an author, what's the proportion that I made to my own papers? So those are quite often conflated in the literature. They are similar, but they are not the same, and they need to be interpreted differently. So both have the same numerator, which is the overlap between your name and the references that are found in your paper. But in the first case, the denominator is all of the citations that you received. And in the case of the references made, well, the denominator is all of the cited references that you made in your own papers. So their interpretation is different, and also they obey different logic. And so if we want to look at deviant behavior, we need to look at the proportion of self-references, because only in self-references is the author in full control of both the numerator and the denominator, because in that case, it really is of all of the things that this person cited, what's the proportion that they made to their own work. So self-citations, self-references needs to be distinguished, and we're going to have a look at both of them. The second thing is looking at self-citations at the individual researcher level rather than at the paper level. So when you look at Web of Science data, self-citations are compiled at the paper level. So any overlap, Web of Science and all of the platforms, basically, any overlap between citing papers in the list of citing authors and the list of cited authors will be considered as a self-citation. That said, when we take that back at the level of individuals, we need to use a different way of compiling that. So let me go through that. So this is a common issue in measuring self-citation. With the paper that I was presenting is a short paper with a big list. One may call that a shaming list by John Ioannidis and colleague. And basically what they provided with this paper is a list of couple of 100,000 highly productive researchers, where you can actually have a look at what's the proportion of what they call self-citation. So what's the proportion of all of the citations that they receive that actually comes from them. And in that list, you have researcher Michael Gretzer, who has received 222,000 citations, of which about more than 16,000 were made by himself. Of course, in that analysis, this is compiled at the level of the paper. And it's a bit misleading because, as you'll see, many of the self-citations that are considered here were actually not made by Michael Gretzer, but by co-authors of the paper. So let me give you a little example here. So we have here a citing paper and a cited paper. The citing paper is co-authored by myself and by my colleague Rodrigo Costas from CWTS in Leiden. In that paper, we cited a paper that was co-authored by Rodrigo Costas. So when you do things at the paper level, given that there's an overlap here between Rodrigo in the citing and in the cited, it's considered as a self-citation or a self-reference. Any overlap here is a self-citation or self-reference. That being said, at the author level, things are different. So for Rodrigo, it is a self-reference. It is also, for Rodrigo, a self-citation. He's citing his own paper. But for me, it's an external reference. That should not count as me making myself a self-reference, because I was not an author on that paper. And same for Ted Van Leeuwen here and Maria Bordons. It should not count as a self-citation for them. It should count as an external citation, because it was not them who made that reference. So when you do things at the paper level, all of those are conflated. If we want to understand individual researchers' self-citation and self-referencing behavior, we need to have things at the paper level. So why didn't we have that? Well, it was mostly because we didn't have good disambiguated data. And this is what we're using here to kind of try to understand the phenomena better at the author level. So this is a necessary step to understand really the behaviors of researcher. We need to look at individual researchers rather than paper level. And as I said, the challenge there is really to have a large-scale author disambiguation. So that cannot be performed manually. We needed to have an algorithm that basically disambiguated the entire database. So what questions do we want to answer? So the first set of questions is to try to understand the dynamics of self-citations and self-references as a function of the career of a researcher. So how do the two type of behavior change as you age as a researcher? And also, how do they evolve as the function of your research output and impact? And the question there is, can you actually become rich with self-citation? Is it possible that some researchers are actually obtaining high impact scores because they self-cite themselves or not? And we'll also look at a couple of differences among them by gender. So are men actually self-citing their stuff more than women? Then the second analysis is to look at the similarity between citing and cited papers as a function of whether it's a self-citation or self-reference or not. So the hypothesis here is that if self-citations are indeed a deviant behavior, then when it's a self-citation, the citing and cited paper should be more dissimilar than when it's an external citation. So in other words, we would see that people who are self-citing their work are citing it even if it's not related to the citing paper. And so this is more of a textual analysis. So what are we using? So using an algorithm for disambiguation, we actually took the entire Web of Science from 1980 to 2018 and clustered authors into more than 51 million authors. So the algorithm is, I mean, not so dissimilar to the one that exists in the Scopus database and some of the others that have been published over the last couple of years. For those who are curious, the algorithm is described in a paper published in 2014 by Emile Caron and Nacian Van Eck. So the heuristics that are being used is, of course, the name and the given name of researcher, their institution, the networks of collaborators, the cited references, topics, and email addresses. And with that, you're making probabilities that this John Smith is that John Smith, and that this other John Smith is another John Smith. Of course, it is not perfect. It is more likely to split researchers into two identity rather than group them. So it actually focuses more on precision within a researcher than on recall that is including all of the papers of that researcher. So overall, we have more than 51 million individuals that have contributed to about 63 million papers, and these papers make 881 million cited references and citations. So this is source items only. As I mentioned, so self-citation and self-reference are compiled at the level of individual researchers, and career age is determined by year of first publication. Moving on to the last point of the methods, there's 4 types of citations or references that we're analyzing here. The first one is direct citation. So that's as the example that I gave earlier, that's Rodrigo citing his own paper. So it's a direct self-citation or self-reference. We also have, to understand that better, co-author self-citation. So that's in that case, for me and Rodrigo, that would be Rodrigo's self-citation becomes for me a co-author citation. Then we also have another layer, which is collaborator citation. So it's people with which I have authored a paper at some point before in my career that cite my work. So it's kind of the network. So the author, the co-author, then the network of collaborators, but not on those specific papers. And then all of the external, that's basically other citations or references that don't fall in any of the above. So first result, and to me, that's a very simple one, but really, really important because it shows the distinction between self-citations and self-reference, and now it evolved over the course of the career. And the implications there is that you cannot expect a young researcher to have the same level of self-citation or self-reference than an older researcher. So let's take the curve for medicine on the top right of the figure. What we see is that in the beginning of the career, the proportion of self-references is close to 0. This is expected. So you're starting your career, you have not written any papers to cite. So basically you're starting it, and you will have globally close to 0 things to cite from you. And then as you age and as you create a trace of papers behind you, then you're going to draw on those papers. And then after 35, 36 years, on average, it's going to be around less than 10%. So on the list of your cited references, it's going to be less than 10%, which are from your own work. So that's kind of the max. So after 35 years of career, the mean value is around a bit less than 10%, actually around 9%. But of course, as when you start, you have nothing from you to say. Self-citations behave in a totally opposite manner. Again, as I said, they obey different logic. So when you start your career, who knows about your work? Well, only you. So the proportion of all of your citations that you have that come from yourself is actually fairly high. And then as you age, this proportion decreases because you get cited, you get known, there's other people than you who can cite your work. And then it basically reaches kind of a threshold after 10 years and then slowly declines. So it's basically 2 phases for self-citations. Before 10 years and after 10 years. So before 10 years, it really drops dramatically. And after that, it kind of slowly goes down. So to me, that's a very interesting and useful curve because, again, it shows how the 2 obey to different mechanical explanations and that you cannot, by conflating the 2, it leads to a lot of imprecision in the literature. And again, the 2 are, we have very different results. So again, if you look at after 25 years, the proportion of overall citations that come from the researchers themselves, it's about 3%. And then self-citations is around 10%. So looking at that, it kind of suggests that self-citations are actually, self-citation and self-references are actually not that important, not that problematic, and that they remain actually fairly low when you look at them at the individual level. Now, splitting that into the kind of other categories. So in red here, you have the direct citation. So that's the exact same thing as the previous slide. Then we look at co-authors citations, which also decrease. So basically, as you start your career, you are citing yourself more. Your co-authors are also citing yourself more. And then your collaborators follow a different path. So there's more and more of the citation that actually come from your collaborators. And globally, the missing part there are all of the external citations. And you can assume that given that most of the curves are going down, the external citations are actually increasing as you age. So as you age, more and more of your cited reference of the reference of, more and more of the citation that you receive are coming from people outside of your social circle. On the other hand, direct references kind of follow the same trend. So they go up, the co-authors actually go down and then the collaborators go up, but I'm going fast on that because I'm seeing that time flies. And I'm gonna skip that one too. Now, by age of citing documents. So the question here is trying to understand, kind of getting into more of the mechanical aspect there. So are you more likely to cite yourself quickly than your co-authors and collaborators? And so if we look at the health sciences here on the right, and the right is normalized. So it means that it's comparing with the max, while the left on absolute is all of the numbers. And you see that again, most of the cited references of the citations are actually external. And so basically the direct citations are the ones that peak the fastest. So your citations are appearing faster because again, you are aware of your own paper, and they also drop the fastest. And external citations, so those again coming from people that you have no links, no publication links with, are actually having a longer life, and same for collaborators. Now looking at the effect on indicators, and I want to mostly focus on the bottom part of the figure. And so what you have here on the x-axis is the observed h-index. And then the y-axis is the increase, the percent increase or the delta of increase in the h-index when you include direct citations, when you include direct and co-authors, and the higher one is when you include direct co-authors and collaborators. So it's trying to see whether you can actually be rich with your self-citations. If it was the case, the line would not be stable. So what you see is that it actually increases until an h-index of about 10-ish, and then becomes stable. And in some fields, it actually increases just for the very, very low values of h-indices. But globally, the proportion of your own self-citations, or the proportion of your h-index that is based on your own self-citation is stable. So it's only basically a 5% increase, which is stable across the board for natural sciences, same for social sciences, and then basically a 4% increase in the health sciences. So your own self-citations have very little effect on the h-index. What has more effect, though, is those of co-authors and of collaborators. So in reality, the effect on the h-index of, let's say, self-citations taken globally is not so much you and your co-authors and your collaborators. It's not you and your co-authors. It's that of your network. It's that of your collaborators. So other people who know your work, that have worked with you in the past, and that go and cite some other papers that you've written. So it really is a network effect. There is, according to that slide, a network effect of citation. And this is something that, again, is not surprising considering what we know about the Matthew effect in science. So the more you're known by many people, the more citations you're going to attract. A couple of correlates of self-reference. So what are kind of the factors that affect the behavior here? So what you have here are, as a function of numbers of publications, the curve for 5 groups of researchers. So those that don't self-cite a lot, so 0 to 60, so there it's the under the median. Those that cite a bit more, but mostly for those, like the 1% of those that are actually abundant self-citers, that they cite their work a lot. Again, calculated as a proportion of self-references. What you see, and that's quite striking, is that those who cite themselves a lot, the 99 percenters, or the top 1%, are actually more cited globally also by others. So the first analysis here is external citations. So as you see, their curve is above, which means that they receive more external citations as a function of their number of papers than those that self-cite less. So basically, not only they cite themselves more, but the community also cite them more. So one may say that they're actually, quote unquote, better researchers, or researchers that have a higher impact. Now, from a gender point of view, we see that these top self-citers are actually less likely to be women. So they're more likely to be men in that situation. And the last one, they're actually more likely to be older researchers. So this is something interesting, and it was shown in some of the other figures too, but I didn't have time to go through it. Older researchers are citing their own work more, controlling for all of the factors, than younger researchers. So it's not a behavior that young researchers have. It's really something that older researchers, by comparison, are more likely to exhibit. I'll go quickly on that. Self-citations by gender. So in blue, you have women. In blue, you have men, sorry. And in orange, you have women. And the proportion of self-citations as a function of total citations. So you'll really see that there's a higher proportion of women, of men's citations that come from themselves. And that is observed irrespectively of the total number of citations. And now if we look at citations gained, again, same phenomena is observed, the same thing is observed. So men are citing their work more. Men are more benefiting from direct self-citations than women. So that concludes the first part of the analysis, where we kind of see that, okay, self-citations are different than self-references, and then that actually it doesn't seem to be that much of a problem. The second analysis is that of the similarity, where basically what we did is we compared abstracts of citing and cited papers. So we had more than 15 million, almost 16 million pairs of cited articles. And globally, given that we're doing that at the level of individual, it has led to a crazy matrix with more than 1.6, almost 1.7 billion cited comparison. We tried to do that on our servers, and it was about to take like 3 months, and we used the Google Cloud, and it took like 24 hours, and it was amazing. So I was very happy to see that possible. So I'm going fast on the method, but it really is trying to get to see the similarity of the citing abstract and cited abstract, removing all of the words that have, let's say, much less meaning. And then this is computed for each reference made and for each type of author. And so what do we see? This is just a distribution where basically, again, most of the references are external. As you can see, the peak is higher. But what is striking is that direct citations are actually more similar. They are much more likely to be similar than citations coming from collaborator or external. So in other words, contrary to our hypothesis, self-citations are semantically much closer between the citing and the cited paper than external citations. So that means that authors are not citing their own work, that are not cited their unrelated work. Actually, authors are citing the stuff that is much more related to the citing piece than the external references that they make. So in that case, that clearly suggests a cumulative nature of self-citation, that researchers are actually drawing on their own relevant previous work on average. Like that's kind of the average that we're obtaining. And as you can see, it's relatively stable as a function of the age of authors. So again, direct self-citations have a higher similarity, much higher than that of collaborators, and that again of external researchers. I'm going fast on that. Then there's a tiny little, let's say, parallel results, which are a bit intriguing and that we're working on. I don't really like that plot, but that's the only way we found so far to analyze it. But basically what it shows is that authors who self-cite the most and who self-cite the least is where the similarity is the lowest. So that suggests a deviant behavior at extremes. So basically researchers that cite themselves, that self-cite a lot, are actually those that, yeah, in their case, they may cite work that is not that relevant to the citing piece. And we also see a gender gap there. So men's paper, especially in the social sciences, the difference is bigger, but it's also observed in the health and natural sciences. So in the case, men seem to be also citing their own work that is a bit more distant than women in the same situation. So that kind of suggests a slightly more deviant behavior for men. So I'm concluding, trying to be on time. So what we found is that self-citation and self-reference follow clearly a different path over the course of the career. Self-citation decrease over time because you get known by other, and self-reference increase in the beginning and then become roughly stable. Self-reference are of course more common for younger document, and the third thing is actually quite important. So external citations are correlated with self-citation. So researchers that are highly cited will also cite their own work a lot. Direct self-citation have very little effect on the H-index once a threshold of like an H-index of 5 is reached. But self-citation from the, not self-citation, but citation from the network of collaborators do have an important effect. There's a clear gender gap here that has been documented using other methods So there's a clear gender gap in referencing behavior. Men are more benefiting from their own self-citations. And then older cohorts are more self-referencing. So contrary, I kind of had a hypothesis that younger researchers who were, let's say, academically raised in the research evaluation culture would be more likely to cite their own work, but it's actually not the case. It's older researchers that are more likely to do that. So to conclude, there's clearly mechanical aspects to self-citations and self-preferences. Younger researchers cannot self-cite much, but they can self-reference. And that's kind of an important point. Therefore, researchers from different cohort cannot be held to the same standard. So if we are to say, oh, you are citing yourself too much, well, we need to control for your age. So again, the expected value in terms of self-reference or self-citation for a younger researcher cannot be the same for older researchers. So globally, our results suggest that in most of the cases, self-citations and self-references are kind of a normal feature of knowledge accumulation. And what we're actually working now to finish the paper is to look at this subset of highly self-referencing authors to try to understand the characteristics and see until what point does it become really a deviant behavior. So I thank you for your time. I hope that this is useful. I know that citation is used by many of you to understand impact, but as you can see, there's still a lot of basic research that can be done to understand how they are behaving and how researchers are actually citing. So thank you very much. And of course, I'm a taker for any questions that you may have.
Okay, well, thank you very much, Vincent, for that amazing and very comprehensive presentation. There's a lot there for us to consider. There's a couple of questions coming in. I'll just quickly highlight for those of you who are new to the area. Professor Larivière and co-author Cassidy Suigimoto published a very helpful, super friendly intro book called Measuring Research, What Everyone Needs to Know, and it's available as ebook format. So anyone who wants to get introduction is super helpful. Questions. Just a couple. Let me switch over here. I'm curious to know where issues of self-plagiarism figure into this conversation, beyond normal career-building practices and abusive research practices. There are ethical reasons why scholars may often be instructed or even obligated to self-cite, i.e. to avoid plagiat.
Yeah, that's a good point. The thing about self-plagiarism is that it needs the full text of paper to be analyzed. So there were a couple of analyses done, but mostly based on a couple of hundred papers. So in order to do self-plagiarism analysis, you need to both have disambiguated data sets at the author level, but also have the full text of the pieces. Self-plagiarism is a controversial issue because if you, let's say, use the same method over and over again, rewriting the method section is seen as, let's say, not so much efficient. So there's authors who will recopy the same thing. When it becomes a problem is when the original previous pieces are not cited. I would also argue that I would strongly advise as an editor to authors to rewrite the methods, but it's indeed, I would say it's part of the ecosystem, and we actually don't know much about the level to which that behavior is important, but it really is indeed it's an unethical thing, which is a bit on the frontier, on the border. And I would assume that actually, I don't know. The question would be interesting whether when there's self-plagiarism, there's also a self-reference that comes with it.
Okay, I think we have time for a couple more. Next question: can you explain why the level of self-references is lower in women? Is there any research on explaining or giving some insight?
Yeah, well, the way it's been explained is that men are actually much less. It's not so much. It's not so much that it's a word for women. It's that it's higher for men. So the way it's been explained is that men are actually a bit more either cynical or that they're a bit less ashamed to cite their own work. They're not shy to say, yeah, I like it. So it's a bit difficult to find one clear reason, but like this is the direction in which the literature goes. So it's more of a cynical interpretation. And there's no, like in the way the analysis is made, it is not due to a mechanical explanation. So in other words, one could have thought that men are citing their work more because they have published more. We control by age, we control by total number of references, total number of papers. And like for similar career age, similar field, similar everything, men are more likely to draw in their pool of previous papers than women. So it really is a behavioral difference, a sociological difference, where men are more likely to draw on their own stuff.
Okay, I think we'll have to wrap it up shortly, but this is a comment that came in, and the comment is, that's a beautiful analysis. I had not considered the difference between self-citations and self-references. Super useful conclusion. We all just assume that self-citations are deviant, but it is not.
Again, there is some deviant self-citation, but at the macro level, it's not, which suggests that if you are doing country or institutional level analysis, including them does not matter. And this has been also shown by others that basically, anyways, the correlation between the two will be perfect.
Well, I think that's the last question or comment that came through. And I think we will, look on the time-wise, maybe just super briefly on the, for myself, on the altmetric side of things, is there an analog to maybe leave us with a last comment on that? Because that's an emerging area.
Yeah, that's a good point. So of course, the barrier to self-tweeting is lower than to self-citation or self-referencing, because you don't need to write another paper. Writing a tweet has no gatekeeping. The problem, though, to assessing self-tweeting is the fact that Twitter accounts are imprecise on the identity of who tweets. So it needs to, in order to do that, you need a carefully crafted list of Twitter accounts that you can actually link with authors of papers. I know there's a couple of groups that have a data set like that, but it's going to be much smaller scale than at the level of papers as we've done. The other way to look at self-tweeting could be done at the level of journals, because we know that many journals nowadays are actually tweeting all of the papers that come out, and these can be considered as self-tweets at the level of journals. So this is actually a very interesting research question. I would be interested to see the results of that. But it needs a carefully crafted data set to measure things properly.
Well, I think, again, due to time constraints, we're trying to get through a lot of presentations. Thank you so much for that incredible, comprehensive presentation. And on behalf of BRIC, you'll probably get something in the mail sometime too, as a token of our appreciation from the BRIC committee and WIN in particular. I think we're ready to move to our next presentation before we break for lunch.
Thanks so much. Bye-bye.
Thank you. Thank you very much.